Hey everyone, and welcome to this explainer. Today, we are tracking the evolution of prompt engineering, and we're going straight up the generative AI maturity model. We're going to start right at the ground floor with the foundational anatomy of a single prompt, and then we'll scale all the way up to complex, multi-model enterprise orchestration using Amazon Bedrock. The way we interact with machines has fundamentally shifted. It's really become a structured engineering discipline. So let's map out exactly how to master it.
So to kick things off, consider this question. Why does asking an AI the exact same question sometimes yield vastly different results? It's a super common frustration, right? You ask a foundation model something simple, and one day you get absolute brilliance, and the next day, complete nonsense. Well, the reason is that talking to AI is no longer just typing a quick query into a search bar. It actually requires a highly deliberate, structured approach to shape the output you want.
And that brings us to prompt engineering. It's the practice of steering a trained foundation model to generate better answers via context, examples, or logical reasoning. And crucially, doing this all without the massive computational cost of retraining the model itself. Think of it kind of like delegating a task to a brand new employee. You wouldn't just walk up to them and say, write a contract, without giving them their specific role, the background context, and a clear goal, right? It's the exact same concept here. Instead of relying on the model's default assumptions, you are actively providing the exact parameters and boundaries required to generate a high-value response.
Here is our roadmap for today. We'll cover 1. The anatomy of a perfect prompt. 2. Teaching AI with context. 3. Mastering prompt management. And finally, 4. Orchestrating with prompt flow. We're going to climb that ladder of generative AI complexity together.
Okay, let's dive into this. Section 1. Anatomy of a perfect prompt, deconstructing how we talk to machines.
Every really effective prompt uses these 6 core building blocks: the instruction, the context, an assigned role or persona, your input data, a negative prompt, and an output indicator. So, for example, instead of a vague request to simply fix a dashboard, specifying detail the steps to fix the dashboard of a Mercedes-Benz GLC Coupe 2024 forces the AI into a narrow, highly accurate output corridor. Or maybe you ask it to write an original short story about a magical dream city, clearly defining the exact creative boundaries. The point here is, the more specific you are with these components, the less room there is for the AI to get confused by ambiguity.
And this brilliantly illustrates exactly what we're talking about. In this Amazon Bedrock use case, we're asking the model to summarize book review feedback. But notice the specific guardrails applied here. We've assigned the role of architect, given the context that it's a technology book, and, this is the really crucial part, we've used a negative prompt, developer role. By explicitly instructing the AI to exclude the developer perspective, the final summary perfectly aligns with what an architect cares about. It just surgically removes the noise that would otherwise completely clutter up the output.
Moving right along to level 2 of our maturity model, section 2, teaching AI with context, boosting intelligence without retraining.
Now, what's really interesting about this slide is the contrast here. Most beginners use what's called zero-shot learning, basically asking a question with absolutely no demonstration examples. But few-shot learning, that completely changes the game. By injecting 1, 2, or even several demonstration examples directly into the prompt's context window, the model instantly maps to your specific pattern and logic. It looks at the formatting and the reasoning of your examples, and then just applies that exact same logic to your new input. It literally makes the model significantly smarter on the fly.
Let's move to and see how this builds into an incredibly advanced technique called chain of thought reasoning. In this scenario where we're calculating mall visitor footfall during Christmas week, the prompt explicitly asks the AI to think step by step. Notice how the generated output naturally breaks down the logic. Step 1, analyzing the given info. Step 2, determining daily expected footfall. Step 3, estimating the weekend. Forcing the AI to actually show its work logically like this drastically reduces the chance of hallucinations and those weird basic math errors. It ensures the final estimate of 21,500 visitors is accurate and easily verifiable by us.
All right, let's step up to level 3. Section 3, mastering prompt management, scaling up for the enterprise.
When you get to an enterprise scale, building a single prompt just isn't going to cut it. You're dealing with massive libraries of prompts, like for a customer service retail chatbot. They require a rigorous lifecycle. It starts with design, sure, but it quickly requires version control. This is absolutely critical for production environments. You have to track your prompts from 1.0 to 2.0 so you can safely audit your virtual chatbot interactions and easily roll back if an update degrades performance. From there, you systematically test against specific metrics, dynamically adapt to shifting business needs, and safely retire outdated prompts that no longer serve your users. It's a whole life cycle, Now, Amazon Bedrock provides some fantastic tools tailored specifically for this lifecycle workflow. A major key to making prompts reusable across massive enterprise use cases is incorporating variables, which you'll often see formatted with double curly braces as placeholders. Because of this, the prompt is never just hard-coded. It dynamically pulls in the user's live context right at runtime, tests and compares different variants, and seamlessly integrates the winning version back into the core application. This effectively shifts prompt engineering from a tedious manual task into a highly automated, scalable system.
So why does all of this matter? Ultimately, effective prompt management comes entirely down to cost optimization and scalability. Think about it. Poorly constructed prompts force users to re-query the AI over and over again, which burns incredibly expensive compute resources on completely unnecessary retries. Proper version-controlled management guarantees a consistent user experience, helps eliminate bad outputs before they ever reach the customer, and actively protects your bottom line.
And that brings us to the final level of our maturity model. Section 4, orchestrating with prompt flow, connecting multi-model AI workflows.
So the crucial point is that prompt flow is a highly strategic enterprise framework. By breaking a massive, complex task into a multi-step workflow, you ensure strict contextual accuracy and optimize your computational efficiency. You are effectively filtering out the noise, routing simple tasks to smaller, cheaper models, and removing ambiguity before you ever hit your most expensive, heavy-duty language models. Plus, a flow architecture makes it infinitely easier to debug and iterate on individual steps rather than trying to untangle one massive monolithic prompt when something inevitably goes wrong.
Take a look at this few-shot learning pattern. Notice how we aren't sending prompts 1, 2, and 3 directly back to the user. Instead, after the LLM invocation, the response funnels through an Amazon Bedrock model evaluation node. This acts as an absolutely crucial quality assurance checkpoint. It scores the generated output for faithfulness, coherence, and accuracy well before the end user ever sees it. If it fails the evaluation, it simply doesn't pass through. This kind of evaluation node is the foundation of building true enterprise-grade reliability into your generative AI workflows.
To sum that up, a well-structured prompt flow strategy is essential. It truly is the architectural framework that takes raw and, let's face it, sometimes unpredictable generative AI foundation models and transforms them into robust, accountable, scalable applications. Applications that you can confidently trust with your customers and your highly sensitive enterprise data.
You've seen firsthand how complex and powerful this discipline has become, scaling all the way from basic context injection to full enterprise-grade workflow orchestration. So I want to leave you with a provocative question to think about. As AI models naturally get smarter and more intuitive over time, will prompt engineering eventually disappear entirely? Or is what we've looked at today simply the foundational syntax for the new programming language of our future? Think about that as you go out and build your own applications. Thank you so much for joining me on this explainer, and keep experimenting.